Sorry. Okay, this is the last big problem that we worked on, other than the comprehensive problem at the end of the chapter. I gave you the problem, the nuts and bolts of it, in an Excel file that you could use in class. But if you want to take a look at it, it requires, it's a nice one. It's a a problem that includes everything in the chapter. So, but it's not crazy. Okay. So this is a real nice problem. I mean, it's a really good example of how you look at different variables to figure out what works best. Okay, that's why I like it. So this is a person who's trying to budget sales for the upcoming year, and she believes the marketing expenditures should help explain sales. Okay, and she also looked at the number of units sold and the number of salespeople working. So she actually looked at 3 different variables here. And the first thing that you do is that you would run single regressions on each one of these. Okay, so when you look at marketing expenditures, you can see the R-square is 0.59, so that explains about 59% of the variance of the behavior of sales. So the marketing expenditures, the coefficient is 2.06. Here's our fixed cost, and we can see that standard error is about 25%, so that's pretty low. Our t-statistic is in fact greater than 1.96. That's a greater than, looks like a 7. And the p-value is less than 0.05. So this is pretty good. Okay, we would say that this is a pretty dependable determinant of sales. Okay, this variable. Then she looked at the number of units sold. Now that only explained 36%. Don't forget these are independent. 36% of the model of the variance, of the relationship between x and y. So let's see. Here's our coefficient is much higher. The intercept is almost the same. I mean, it's just a couple thousand less, or 2,000 rather less. Than marketing expenditures. And our standard error, though, is a little bit higher. You can see I think we looked at it in class, I think it was about 42%, around there. And the t-statistic, okay, is still greater than 1.96. And the p-value, although not as strong as marketing expenditures, it's still less than 0.05. So this would be a good variable too. Okay? Then we looked at the number of salespeople. Now the first thing you want to notice here is that the R-square is abysmal. It's so surprising too that the number of salespeople only accounted for 0.01. Okay, so 1.11% of the variation. Okay, that's all it could explain, which is pretty bad. The coefficient is much higher. The standard error is crazy high. Okay, so it must look, it would be interesting to see this data and to see what a scatter plot would look like. And then here's our t-statistic. The t-statistic is not, I'm going to go like this, is not less than 1.96. It's not a dollar sign, it's a not. Okay, so that's not a good thing. And the p-value is 0.74, which is not, I'll do this, not less than 0.05. Okay, I'll say not here. So now that we looked at each one individually, then we start doing some multiple regression and combining the variables. Okay, so and that's what's down here. So let's take a look at this. Okay. So it takes a little bit of looking to figure out what you're looking at here. The first one is if we look at marketing expenditures and the number of units sold, or the number of units sold and salespeople, or marketing and salespeople. Okay, so we want to see how much that changes. And the first one, if we look at marketing expenditures and number of units sold, that R-square is 0.6076, so over, say, 61%. Okay, of the it would say that the model fits pretty well. Not all that much better though than just marketing alone. Okay, so when you add other variables in, it kind of muddies the water a little bit. You really only want to add them in a limited number if they really add value to the model. Okay, I'm not sure it adds value, but it's not bad. Okay, or if we look at the R statistic, I didn't even notice that before. Well, we have to look at them individually, but you can see that the p-value, let's focus on that, the r-square and the p-value here. I'm not sure what to do with this. Oh, that's a t-stat. I wonder if it's a typo. I'm not sure. It might be. Okay, but these are both greater than 1.96, so that's good. Whoops, I'm sorry, these two are both, no, the number of units sold is not greater than 1.96. Okay, but the marketing expenditures are, so I think marketing is really carrying this. Okay, number of units sold, it just doesn't really predict sales. That's what this says. And you can see the p-value bears that out, that the p-value for marketing is 0.04, which is less than 0.05, so this is the one we'd be interested in. Okay? And then the next one, if we look at the number of units sold in salespeople, that's 0.36, okay, which is almost exactly the same as what it was with just the number of units sold. Okay, and you can see that if you look at the number of salespeople, it's actually negative. Okay, it decreases the strength. The standard error, here's our coefficient, minus 539. The standard error is 7,066. The data would have been fun to see here. It would have been nice. And then if we look at the t-statistic, it's negative here. And this is 2.21, so this is the only one that would be good there. It's greater than 1.96, and the p-value is 0.05. This is ridiculous. It's almost 1, which would mean anything it would predict would be wrong. Right? That's what you could conclude. And then the last one here, she's got the marketing expenditures and the number of salespeople. And again, it actually, let's see, our R square for marketing alone was 0.5968. This one is 0.5974. Okay, which is, you know, there's not enough difference at all between the two. The t-stat and the p-value for the number of salespeople is terrible. No surprise there. And marketing expenditures still comes up pretty good. Okay, there's more in the Excel file that you can look at, but that's what we're doing here. We spent a lot of time in class on this, but if you still don't get it, don't hesitate to contact me. Okay? All right.